We're going to solve the equation cos 2 theta equals 5 cos theta plus 2 on the interval from 0 to 2 pi. What is good about this equation is that on both sides of the equal sign we have the same trig function, that is cosine. However, on the left hand side, cos 2 theta is actually a double angle, while on the right hand side 5 cos theta, that's a single angle. So the first thing we would do, intuitively, we would bring the 5 cos theta and the plus 2 across the equal sign. So we bring everything over onto the left. However, we still do not have a quadratic equation. This is cos 2 theta, not cos squared theta. So this here is actually not a quadratic equation in cosine theta. What we can do at this point is make use of the double angle formulae. So cos 2 theta, we would recall that we learned 3 different versions. Cos 2 theta is equal to cos squared theta minus sine squared theta. That's one version. However, this particular version would not help because we have 2 different trig functions, cosine and sine. The other version we learned was that cos 2 theta is equal to 1 minus 2 sine squared theta. But again, this is going to lead to us having a sine term and a cosine term. The third version of cos 2 theta is that cos 2 theta is equal to 2 cos squared theta minus 1. This one is very useful. So we replace the cos 2 theta with 2 cos squared theta minus 1. And this will allow us, once we distribute the left hand side, it will allow us to set up a quadratic in terms of cosine theta. 2 cos squared theta minus 5 cos theta minus 2 minus 1 will give us minus 3. Being equal to 0, this will factor into 2 cos theta by cos theta will give us 2 cos squared theta. And to get minus 3, we can multiply minus 3 by plus 1 or plus 3 by minus 1. The two numbers will actually be, this would have to be plus 1 and minus 3. To give us back the minus 5 cos theta, we have 1 by cos theta gives us plus 1 cos theta, and minus 3 by 2 cos theta gives us minus 6 cos theta. So of course, plus cos theta minus 6 cos theta gives us minus 5 cos theta. So when we distribute these two factors, we will get 2 cos squared theta minus 5 cos theta minus 3. 2 cos theta plus 1 is equal to 0, or cos theta minus 3 is equal to 0. Looking at the second factor, cos theta would have to be equal to 3, but we know from our knowledge of the cosine function that cos theta takes values between plus 1 and minus 1. Therefore, cos theta equals 3 has no solution. We don't need a calculator to tell us that. 2 cos theta plus 1 equals 0 means that 2 cos theta is equal to minus 1, and therefore cos theta is equal to minus 1 over 2. The reference angle alpha is equal to cos inverse. Remember, we take the absolute value of minus a half. Cos inverse of a half is 60 degrees, which is pi on 3 radians. And again, we need to know where is cosine negative. So this negative sign, again, it only tells us which quadrants we need to pick up solutions from. Cosine is positive in the first and fourth quadrants, and therefore it's negative in the second and third quadrants. So we place our reference angle in the appropriate quadrants, and the angle that we're going to pick up in this second quadrant, I'm going to highlight it here. It's this angle, which is 180 minus pi on 3, or that would be pi minus pi on 3. So theta is pi minus pi on 3 in the second quadrant, and in the third quadrant we're going to pick up this angle. I will highlight it all the way around there. So that's a full semicircle plus pi on 3. So that's pi plus pi on 3, which is 4 pi on 3. Right? Pi plus pi on 3. So theta is equal to pi minus pi on 3, which is 2 pi on 3, and pi plus pi on 3, which is 4 pi on 3. And these are the two solutions for 2 cos theta plus 1 equals 0. And they are also the only two solutions we have for our original trig equation, cos 2 theta equals 5 cos theta plus 2, because you will recall that the other factor, cos theta minus 3, when we set it equal to 0, we get no solution. So the final solution set for cos 2 theta equals 5 cos theta plus 2 on the interval from 0 to 2 pi is 2 pi on 3 and 4 pi on 3.